Hi. Today we'll discuss nomenclature of carboxylic acids. It is a continuation of nomenclature of organic compounds, and we are starting here the nomenclature of organic compounds with the prime functional group. This is the first example. So we start here our discussion with the carboxylic acids. Some basic discussion already we have done. Now few things, some information you need regarding carboxylic acids, regarding functional groups. So first thing is this one, that the compound having this structural unit COOH is called carboxylic acid. This functional unit, this structural unit is carboxylic acid. Okay. Here other important information regarding this is suffix, prefix. So you understand this one, that here the suffix is oic acid, and one more suffix it has, that is carboxylic acid. Carboxylic acid is another suffix. We will discuss that when to use the oic acid and when to use the carboxylic acid. Both are suffix for COOH group. There is prefix also for this one. Prefix is there, and prefix is carboxy. The best way to deal the nomenclature is to start with the example so that you will understand it better. Right? I'll start with one very basic example, that CH3 C double bond O and OH. In this compound, COOH structural unit is present. This is acid, this is the carboxylic acid. How it is named? Very simple one. First what we do, that you see. First thing is this one, that this carbon is considered first, this one is second. We form the parent chain. And regarding this functional group, you need to remember, you need to understand this, that this is called terminal functional group. What we say this one? Terminal functional group. This is one of the term. What is important for you? Terminal functional group. What is the meaning of terminal functional group, you can ask me? Terminal functional groups are those functional groups which essentially form one of the terminal of the parent chain. The parent chain starts with the carbon atom of this kind of functional group. And that's why we say terminal functional group. Sir, any other example? Yes. Many examples are there. Most of the carbon containing functional groups are terminal functional groups, like COH, COOR, ester, COCl, acyl halide, CONH2 amide, C triple bond N cyanide, CHO-aldehyde. All these are carbon containing functional group in terminal functional group. So whenever these functional groups are present, the carbon chain usually starts with the carbon atom of these functional groups. And so in this case we have started with this carbon atom 1 and 2. So we consider here that in the parent chain we have the 2 carbon atoms. This is the parent chain. And for this we use the term eth. In this chain there is no double bond, no triple bond. So the primary suffix is "-in", "in", "ein". Will be the "in". And so the name will be there that eth plus "-in" plus oic acid. Eth plus "-in" plus oic acid. In brief, when you join together, you will write here ethanoic acid. What do you write here? You write here ethanoic acid. Here, it's a small only but important, that "-in" is the primary prefix which indicates whether the compound is the derivative of this alkane or alkene or alkyne. It is the word root. Oic acid represents here the acid. As I explained here that 2 carbon atoms are in the chain, then some of you, especially who are listening first time, may start thinking, that, sir, then oic acid, this suffix term represents what? Does it represent COH? No. It is not representing COOH. Actually, this suffix term, what we use, oic acid, is that kind of suffix which is used only when carbon atom of this COH group is the part of the parent chain. This is the technical point. Now you will get the other thing also. So it is very clear that whenever the COH group is named, that is named in parts. Carbon atom becomes the part of the parent chain, and double bond OH truly represented by the oic acid. So now you are very clear what is the meaning of ethanoic acid. Eth term includes carbon atom of the COOH also. Many of you who have already done nomenclature might be thinking that why this person is insisting on this small point so much. Might be thinking. But for the clarity, it is very much required. Because with that much insistence, you will start understanding the significance of the carboxylic acid. And now you will understand that what is the significance of the carboxylic acid of this suffix. What is the significance of this suffix? Very clear. When the carbon atom of the COOH becomes the part of the parent chain, oic acid, this suffix is used. When there the carbon atom is not the part of the parent chain, then the carboxylic acid is used. Very clear. Sir, any examples? Yes, why not? You see this one? That we take here this compound, C double bond O, and there the OH. In this case, this is the cyclic part, and that only is the parent one. There are the 3 carbon atoms in the ring, so you cannot say cyclobutanoic acid. There is no point of saying this one, because 4 carbon atoms are not in the chain. So we are forced, we cannot incorporate here this carbon atom of COH in this chain. So significant 2 parts are different. COOH you have to name separate, and this one separate, and so the name is cyclopropane carboxylic acid. Yes, this one is cyclopropane carboxylic acid. Carboxylic acid. Understand this? So, very first, my intention is to explain you the significance of suffix, the uses of suffix, where and how to use oic acid, where and how to use carboxylic acid. And I hope you are clear. Whenever you can include this carbon atom in the parent chain, you must try. Then oic acid, if this carbon atom is not getting included in the parent chain, then carboxylic acid. Fine. So this part is clear. You say this one ethanoic acid, you say this one cyclopropane carboxylic acid. Take here for better clarity few more examples, and then we will define here that how carboxy is used, how prefix. This is the other part. Yes, you see this one. I discuss here one more example. There, that better clarity we need. H, C double bond O, OH. What means it contains 1 carbon atom. And we consider this is the chain. So this one is methanoic acid. Methanoic acid. If CH3, CH2 and C double bond O and OH is 1, 2, 3, 3 carbon atoms are there. Then propanoic acid, propanoic acid. Then we'll use here propanoic acid. Yes, some of you can ask me, sir, you are not writing the position of this COH. You can write propan 1 oic acid. But by default meaning is same. Whether you write propanoic acid or propan 1 oic acid, meaning is same. It is an essentially this COH group is the first one. That's why there is no confusion and you can manage without this locant one. Right? Okay. Here my first purpose is to make you familiar with these terms. So suffix you got, now you take the prefix. Prefix is COOH for this one, carboxy. When we use the prefix to, prefix term we use for those functional groups or substituents which are not the prime functional group. When a molecule contains more than one functional group, then the highest priority functional group is expressed, indicated with suffix, and rest all the functional groups are expressed with the prefix. When more than one functional groups or the substituents are present, then the highest priority substituent is expressed with suffix, and rest all are treated as substituent, normal substituent, and expressed with prefix terms. Then immediately you will get the idea, because you know earlier in the last class we discussed the priority order, and in general you know the priority order. Priority order, you think that COH is on the top. COOH is, honestly speaking, not on the top. If you think of the priority order, priority order, okay, very first on the top we have radicals, okay, radicals. Then there are the anionic species, anions, then cations, then deuterionic species, then acids, carboxylic acids. So here the position is like this. So radicals, if we have radicals or they're the anionic species or cationic species, in that case, these are considered of higher priority, and suffix will be expressed, will be used for these terms, and the prefix will be used for the acid. Sir, one example. Yes, take example. Take example for this one. Here, I take this only example. This one is CH3CH2, so we say propanoic acid. We make it salt. CH3CH2, C double bond O and O minus. What is this now? If this one is a propanoic acid, then what is this? Both are same or different? Both are different. This one is propanoate. This one is propanoate. You know, this one is salt. This one is anionic species. Here, the functional group is changed. This is no more acid. This is salt. This is the anionic species. And that is expressed as the propanoate. Let's take here one example. Take here one example. I write here the C double bond O and OH, CH2, 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 and C double bond O, O minus. Very basic question I want to ask. How many functional groups are there in this molecule? There are two. As I discussed here, that this COO minus is functionally different from this COOH. So this one is anionic species, this one is the acidic. For this one, separate nomenclature, for this one, separate nomenclature. And so in this case, this will be named like this. This is also carbon containing functional group, terminal functional group, this anionic species. And so this one is 1, not COH. This one 2, this one 3, this one 4. And then now this one is treated as substituent. This is the prime functional group, higher priority functional group, and this one is lower priority and treated as substituent, and for this we will use prefix, and for this we will use the suffix. Suffix is very clear. This one 4 carbon atoms, that's why we say butanoate. How to express this COH? With the prefix. And what is the prefix for COOH? carboxy. So what's the name for this one? We say 4 carboxy. On the 4th position we have, so we say 4 carboxy butanoate. Butanoate. This one is 4 carboxy butanoate. Right? I hope you got this point, that how and where prefix of CH group is used. I gave one more example. Let's take here one more example. Okay. This one is pyridinium chloride. This one is pyridine. When this reacts with HCl, this forms like this, and this one is pyridinium chloride. Pyridine and HCl reacts, this one is pyridinium chloride. Up this one is the cationic species. Here this is considered of the highest, much higher priority. Now if COH group is present in this ring, then how to name this? Yes, COH is treated as substituent. And so, with respect to this one, 1, 2 and 3, we say 3 carboxy pyridinium chloride. 3 carboxy pyridinium chloride. Yes, it is named like this. Now, it is very clear that how and where we use prefix of CH. We will discuss now the main course of our discussion. There in all aspects. Let's take here new one. For example, you take here this kind of example. There regarding this, you see, if the COH group is present, then the very basic rule is the parent chain must include COOH functional group irrespective of number of carbon atoms in the parent chain. That may be less, there is no problem at all. But COOH group must be there. For example, just you see, this is the best example for this purpose. No. Here, you see, if you take here this as parent chain, 1, 2, 3, 4, 5, 6, 6 carbon trips are there in the chain. But no. As the COH group is present, COH group is the terminal functional group that must be the part of parent chain, and the carbon chain must start with carbon atom of this functional group. So the carbon chain starts with this parent chain starts with this one. This is 1, this one 2. Yes, after that you have the choice. After that you can use this choice, longest possible chain. Including this one, you must try to form the longest possible chain. And so now 1, 2, this one 3, this one 4, this one 5. This is the longest chain. What about this? Yes, this one is the substituent. What is the substituent? Substituent is ethyl. Where is this ethyl? On the 2nd position. So what is the name of this compound? Very simple. That this one is on the 2nd position ethyl, so this one is the 2-ethyl. And pentanoic acid. 2-ethyl pentanoic acid. This one is pentanoic acid. and so 2-ethyl pentanoic acid. This is very clear. This rule is clear that parent chain must include the COH group irrespective of number of carbon atoms in the chain. Numbering starts with the carbon atom of COH, including that when we try to form the longest possible chain, and rest of the substances are arranged alphabetically. That is the normal route applicable. Right. Now you see this one. In this case, you see this one. Here, if there is double bond, in that case. Now, if there is double bond or triple bond present in the molecule anywhere, right? First thing is COH. Second thing is double bond or triple bond. Double bond or triple bond. Third thing is the number of carbon atoms in the chain. Third thing is there the number of functional groups in the chain. Third thing is there alphabetical order and all that, right? All those are the third thing. First COH group, a second the presence of double bond or triple bond. So take this one. In this case you see this one. In the normal case, if you consider this one, yes, this one is 1, this one 2, this one 3, this one 4, this one 5, this one 6. Normal course, if you see, you find here the chain of the 6 carbon atoms, including double bond. Earlier we learned like this, but now, no, because now we are dealing with functional group. Functional group must be there, so this is fixed. As this is terminal functional group, so this is also fixed. This is one. Next, starting with this one, we go to the second position. Now what to consider? What to consider? If we go this way, we get here that 2, 3, 4, 5 carbon atoms in the parent chain, and if we go this way, we get here 3 and 4, only 4 carbon atoms in the parent chain. So what? Yes, we prefer 4 carbon atoms in the parent chain because it contains a double bond. So, including COH kind of functional group, parent chain must include double bond or triple bond if present in the molecule, irrespective of number of carbon atoms in the chain. Yes, this one third, this one fourth, this one is the parent. Then what about this? Yes, very clear. This one is substituent, 3 carbon atoms, propyl. Where is this propyl? On the second position. So what you will say? You will say here the 2 propyl. And in this case we have the 4 carbon atoms, so the word root is but. Double bond is there, so now it is the derivative in this parent chain. In the carbon chain there is double bond, so it is the derivative of alkene, and that primary suffix will be in. But this in may be there on any other place, no? Maybe they're in between 2 and 3, maybe they're already there in between 3 and 4. So we have to make it very clear, where is this double bond? Yes, that will be right. We write here 2 propyl but. Which place double bond is there? Third place. So we write 3 En. We don't write Ene. We don't write. We write En because after that oic acid comes. So the Ene, this vowel drops as the another coming. Later is the O vowel, so this is dropped. So 3 in 1 oic acid or enoic acid. Anything you can write. 3 in 1 oic acid or enoic acid. 2-propyl but 3 enoic acid. So if the double bond is there like this. And not only that one, if more than one double bond is there, then also we don't care. Then also we should see this and that parent chain must include first functional group, second there the double bond. We must try to include the maximum number of double bond or triple bond, but this is not so compulsory. Whatever maximum you can include, you include. After that, as I told you, third thing is the number of carbon atoms. Let's take here. Chain in this case will start from here. This is 1, this is 2. Now double bond is this side also, that side also, automatically, right? No? So this is so natural, very general rule, general understanding that as double bond is anyway present both the way, this way also, that way also. We choose here with the more number of carbon atoms. So this one is 2, this one 3, this one 4, this one 5 and 6. So now we are not able to include this into the parent chain. We can't. So this will be treated as substrate, and so this substrate is called vinyl, and that is well accepted name for this one, vinyl. Although systematically you can say eth, in-yl, but vinyl is also well accepted in the IUPAC nomenclature, so mainly vinyl is used, although systematic nomenclature is the ethinyl. So we'll say here, there the 2-vinyl, 6 carbon atoms are there, hex in the parent chain. Where is the double bond? Third place, 3 enoic acid. 3 enoic acid. 2-vinyl hex 3 enoic acid. I hope you got this point. Now you see that if there is double bond as well as triple bond, you might be getting this idea, sir, what will happen? The double bond and triple bond both are there. Which will be the part of the parent chain? What is the parent chain? Yes. So in this case, you see this one in this discussion, that no doubt carbon chain starts with this one, this is 1, this one 2. Up now, this way if you go, triple bond we get, that way we get, go, double bond we get. There is no advantage this side and that side. This side only difference is ion, that side in. Number of carbon atoms are same. So, in has alphabetical significance, alphabetical precedence. And so, in that case, when the situation is tie all the way, in that case, double bond gets priority because it has alphabetical precedence. So, this one is 2, this one 3, this one 4. Then this one is treated as substitute. And very simple word. You say this one what? Ethinyl. Ethinyl. So where it is on the second place, we write here ethinyl. And then 4 carbon atoms, so but. And 3 enoic acid. 3 enoic acid. This done. Now the point is, if there is difference in carbon atoms, many of you have this kind of thinking because number of books have written the double bond has higher priority, at least higher priority than this triple bond and all that. Written, very clearly written, but not clarified. And that's why that creates lots of confusion. Now you see this one, it will be more clear. This one is 1, this one 2. what way you will go? This side we have triple bond, that side double bond. Will you take here the double bond? No, 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 no. You won't take. Because double bond is not giving that much priority. Triple bond is there and more carbon atoms are there. Double bond and triple bond both are seen from the same eye, right? If all other features are same, then double bond is getting priority. But if number of carbon atoms are different, then this one is getting favor, and this one is third, this one is fourth, this one is fifth. And now, in this case, this one is treated as substituent. Right? So, now what you will say? You will say this one. On the second position, we have substituent, that is the 2-vinyl. And this one is pent, 5 carbon atoms. Pent. Triple bond is there, the 3-ion, oic acid. Yes. 2-vinyl, pent, 3-ion oic acid. Right? Whatever confusion is there in your mind, I have given here the example exactly on that one. And this is the most authentic information. Most authentic. No one can challenge. Right? This one is 1, this one is 2. Now what to do? This time, as I told you, this contains more number of carbon atoms with double bond. This contains triple bond with less number of carbon atoms. Right? No one is our relative, huh? Neither this triple bond nor this double bond, right? As this contains there the more number of carbon atoms, we do favor of this one and we take here 3, this one 4, this one 5. Shall let's see here now. In this case now, this one is substituent. Okay? But ethynyl, and this one is the parent one. So you will say this one now 2 ethynyl, substituent, 5 carbon atoms, pent. Now double bond on the 4th position, 4 in oic acid. Yes, it is clear. It is clear. I hope all dots related to double bond, triple bond in the parent chain clarified. Clarified. You cannot think any extra example or any extra case, right? I have included all that, right? Okay. Now we'll move to the next one. You see this one, that one, more question may be there in your mind. That is all related to the functional group. Generally, you will find there the rule in the book, many of the books, that parent chain includes maximum number of functional group. This is misinterpreted. Don't misinterpret that rule. Rule is correct. Maximum number of similar prime functional group. It's not like this maximum number of functional group. No. You see this one? Here we have CH group. If you go this way, we have the double bond, and if you go this way, then you have CH group, one functional group, OH group, second functional group, CH3 is one substrate, Br is another substrate, 1, 2, 3, 4, and this one is the 5. 5 substrates are there. More functional groups are there, but we don't choose this as a prime parent chain. We don't include, we don't consider. After this prime functional group, including this one, we must try to include the double bond in the parent chain. Then there the more number of carbon atoms. Then there the more number of substituents, right? Then there alphabetical precedence, right? So certainly we don't care these substituents, more number of substituents. We don't care. We don't care. And so we decide this one is 1, this one 2, this one 3, this one 4, this one 5, this one 6. This is the parent. We have decided. And this is the way you have to do. Then what about this? Yes, this one is treated as substituent. As this is the parent chain, and this carbon is connected to this one, so this one is 1. This is the chain of parent chain of the substituent. And this substituent contains here one substituent OH, there the CS3, and there the Br. OH is not the functional group. This one is simply treated as substituent. Right? It is not a prime functional group, it is a functional group, but treated as simply substituent. Right? What is the name of this? Very clear. Alphabetically we write here. What we write here, on the third position we have this one. Third position we have. What we have? This is the substituted substituent, so that must be written inside bracket. And so alphabetically if we write, then this one is 3 bromo. 3 brom, 1 hydroxy, 1 hydroxy, 2 methyl propyl. This is the name of the substituent. 3 bromo, 1 hydroxy, 2 methyl propyl. This is the substituent, and that is present on the third one. And then the parent chain is there the 6, so we write here the hex. Fifth position double bond, 5 in oic acid. Oic acid. Yes. So even this confusion you should make clear, right? That number of functional groups not required. Yes. Again, one confusion is there. And my next example is ready for that also. Right now? Yes. You see, these examples will clarify all that. Right? More number of functional groups, similar functional groups, 2 CH groups. Parent chain must include the maximum number of similar prime functional groups. Okay, it's very straight, very clear. This one is 1. We try starting with 1. We try to include maximum in the on one terminal, 1 CH, other terminal, other CH. This one is 2. This one is 3. 3 carbon atoms. 3 carbon atoms are in the chain, so this one is pro. There that no double bond, triple bond in this chain of 3 carbon atoms, so the propane. This time we write E. Why E? Because we know that the 2 CH groups are there, so we write dioic acid, where 1,3 dioic acid. One thing I want to tell you, you write simply propane dioic acid, that is also correct. Propane dioic acid, this is also correct only. A propane 1,3 dioic acid, that is also. Because there is no confusion, propane dioic acid means this only. Right? What about this one? 1 into, you will say ethane dioic acid. This one is ethane dioic acid. For your guide information, this is important. Even we will discuss separately. They are the common name system. And so you see here, this propane 1,3 dioic acid is called malonic acid. Malonic acid. This is the common name. You should know parallel. This one is oxalic acid. What about this compound? I mean, this compound, the same thing is there. That idea what you had, the parent chain must include the maximum number of functional groups. How you interpret that? You may interpret that if we take this as a chain, we get this functional group, we get that functional group, we get that, right? And that way we will have more number of functional groups. No, that is misinterpretation, right? When we say the more number of functional groups, it means similar functional groups. I just repeatedly insist on this one because I have seen number of students misinterpreting this rule. Right, sir? Please be careful. Okay? So in this case, this one is 1, this one 2, and this one 3. Yes, less number of carbon atoms, no problem. No double bond, no triple bond, no more number of substitutes, not a problem. As it includes there the 2 maximum number of similar functional group 2, that's fine. This is the parent chain contains 3 carbon atoms, and now this one is treated as substituent. This is treated as substituent. In the substituent, the free valent carbon atom is the first one. In the substituent, essentially highest priority position locant is first always for this free valent. So this one is the free valent one, so this is 1, this one 2, this one 3. And interesting, for this one we use the term formyl. This one is hydroxy. And we say on the second position we have second position we have this substituent. And what substituent we have? We have 2 formyl, 3 hydroxy, 3 hydroxy, propyl. On the second position we have this substituent, 2 formyl, 3 hydroxy, propyl. And now what about this? This one is propane dioic acid. This one, the rest of the part is propane dioic acid. Sir, okay, this is fine, not more functional groups, but if the double bond is there, more number of carbons, then also no means no, right? Then also this only is the parent one. And so you understand here, okay? That this example you consider COH, CH2, CH. Yes, we take here this one 1, this one 2, this one 3, this one 4. Sir, why you have not taken this one? Because if you take this one 1, 2, 3, this carbon will be third one where we'll have this substituent. Anyway, this is the substituent. Anyway, this one is substituent, and if we start from here, that will be on the third position. If we start from here, that is on second position. What is the name of this? This one is 1, this one 2, this one 3, and 4. And we say on this second position we have one substituent, that is but. There the 2 in 1 aisle. But 2 in, on the second position we have in, and we have free valency on the first position, that's why 1 aisle. It needs clarity. If you say simply but 2 in aisle, may have some confusion. Although meaning is there, the aisle means free valent only will be the first one, but needs more clarity. So 2 but 2 in 1 aisle is the name of this one, and this one is butane dioic acid, right? 4 carbon atoms, so this one is butane dioic acid. Yes. I hope this aspect we have touched everything. On this aspect we have touched everything, all possible confusion, all possible examples clarified, right? As we are discussing here the mode number of CH groups, one very interesting example is there, right? We will discuss that. One very interesting example is there, you know what? You see this one. These are very interesting examples because in this case, rule is changed. Rule is changed. You take here the first example. In this case, we try to form the longest possible chain, and the longest possible chain can include how many CH groups? Maximum 2 terminal functional groups. So, when we start forming here the so-called parent chain, we can include maximum 2, and so this is 1, this one 2, this one 3, 4, and 5. But this is also CH group. What about this? Yes, you have touched, but you have not included. Now you are including the carbon atom of this, you are including carbon atom of that, and this is directly connected to the chain, and you are not including this one. It is a big injustice. This injustice was there, prevailed for a long time, and initially they advised, okay, if this is the condition, you include maximum number of prime functional group, and you treat this as a substituent. And so the IUPAC suggested the name like this only. Then this is treated as substituent. As a substituent, its name is carboxy. So it was said there the 1, 2, 3 carboxy. And this one is pentane dioic acid. Pentane dioic acid. It prevailed for a long time. But later realized, yes, it is injustice with this CH group, right? Because this is also CH group. बेचारे के लिए तो कुछ तो करो जी. Yes. Now, justice accepted. So then, if this kind of situation is there where we have more than 2 such carbon containing, I mean to say terminal functional groups in the so-called parent chain, then we don't include any terminal functional group. We don't include the carbon atom of any functional group. Don't include this one. Don't include this one because you are not including this one. As you are not including the third one, fourth one, fifth one, which are directly connected to this one, then you don't include the first and second also. Justice done. New rule, right? And as per this new rule, here the parent chain is left with only 3 carbon atoms. 1, 2, 3. These are not the substituents, these are the prime functional group. In the beginning we learned one rule. What? When the carbon is included, what suffix? Oic acid. When the carbon is not included, what suffix? Carboxylic acid. Yes, we have respect for the CH, that is the prime functional group. But the carbon atoms of these functional groups are not getting included in the parent chain, then what? Carboxylic acid. So we say this one, this is the old one, new one is propane, yes, 1, 2, 3, 1, 2, 3, tricarboxylic acid, tricarboxylic acid, yes. 3 CH groups are there, so try carboxylic acid. Yes, I hope it's not difficult to understand. You might have enjoyed, and now it is very clear. This is also very clear that how these people are just improving rules, making this more scientific and logical. Yes. Human touch in the rule. Right? Okay. Now in this case, how to deal this with the same rule? We are trying to form this as the longest chain, but this is directly connected to this chain. So this is not getting included. If this is not getting included, this is also not getting included. Then this is also not getting included. In this case. Now these are the functional groups, so little basic touch of rules we add. We take this one as 1, this one 2, this one 3. We are not taking this as 1, 2, 3. Because on this place we are getting the 2 CH groups. So this one is the propane. Yes. Propane. 1, 1, 3. 1, 1, 3. Try carboxylic acid. Try carboxylic acid. Yes. Done. Okay na? Done. Interesting. No. Yes. What do you say about this example? Is it the same example? Read carefully, huh? Read carefully. Is it the same example? Here. 1, 2, 3, 4, 5. We try to form one of the parent chain of the 5 carbon atoms, including here the 2 CH groups. Is there third CH group connected to this so-called parent chain? No. No. Third CH group is present, but not getting connected, not directly attached to that possible, longest possible chain. Then certainly this rule, this case is different from this one. Then enjoy basic rule, right? Basic rule, make this as the parent chain. Now what we will do? When this CH group is not coming in front, then how much we can support this one, right? Fine. This is. Then sir, how to name this one? Yes, this is the issue that we have to tackle. We take this one as a substitute. This thing anyway, you know, 1, 2, 3, 4, 5 pentane dioic acid. What is the name of this one? This substitute? CH2CH. Ethanoic acid, huh? नहीं चलता. Then COOH group is not directly connected. This one is connected, and so carbon is connected. So here you have to consider this is the substrate of this one. For example, if you have the CH2Br, CH3 only CH3 then methyl. If CH2Br then bromomethyl. If CH2OH, hydroxymethyl. If CH2COH, carboxymethyl. Yes, correct. Carboxymethyl. So we write here 3 carboxymethyl. Right? We write here 3 carboxymethyl pentane dioic acid. 1, 2, 3, 4, 5 pentane dioic acid. Pentane dioic acid. Yes, you learned good, clear. This is correct. This one is different from that one. Okay? This one is different from that one, those rules. Okay? This one is different. Okay? Is it over? No, no, it's not over. We have few more examples. Please bear me, right? We'll take here few more examples. Although simple one, right? No? Simple. But we have to finish this one. Here, what is this? Anyway, you know. When the COH group is directly connected to the ring, this carbon atom cannot be included in the ring, and that's why, how do we name this one? We name this one cyclo, right? We name this one cyclopentane carboxylic acid. Carboxylic is cyclopentane carboxylic acid. But if this one is not directly connected to this ring, then no problem. Then that will be treated as substituent. Because if any carbon atom is there in between there, the ring and the COOH kind of functional group, then that will form separate chain. That is the chain. Now, sir, somewhere in this one given that cyclopropyl methanoic acid, sir, given many things given, there are so many system of nomenclature, huh? That is not the dieback system. That is the CAS, chemical abstract system, a special system of USA, right? Given in many of the books. They are mixing, don't know what to do and where to do. So be clear, no confusion. If these functional groups, carbon containing terminal functional groups, are directly connected, that is the property of the ring, that is the prime functional group of the ring, will be treated like this. But if not directly connected, then this one, this one is what? Yes, this forms chain because this contains such important functional group. This will be treated as substituent, and then we say this one is 1, this one 2, and we say 2-cyclopentyl ethanoic acid. Ethanoic acid. Yes, correct. In the ring, this is also important, huh? Double bond is there, huh? This one is double bond. And now COH group is there. Double bond is there. Other functional groups are also there. The other functional group, how? When big boss is there, COOH, highest priority, one of the highest priority functional group, then all others are treated as substituent. OH group is substituent. Now this substituent is getting importance of this double bond, certainly double bond. And that's why this one is the first carbon atom, and we don't care, this OH group. Don't be emotional, right? So this one is 1, this one 2, this one 3, this one 4, this one 5, this one 6. Yes. And so we write very clearly that the 6-hydroxy, 6-hydroxy, cyclohexane, double bond is there on second position, 2 in, we write E because we are not going to use oic acid, COH group is there, so carboxylic acid, in 1 carboxylic acid, carboxylic acid. देखने में अच्छा लगता है, that's why I have given there the one. If you write there the carboxylic acid, no problem, right? What about this case? In this case, you may have sometimes excuse. Sir, both are on the same position. That's why we have given. Even these two are not on the same position, then also double bond only will be given priority, right? So this one is 1, this one 2, this one 3, this one 4, this one 5, 6. If we take this way, 1, 2, 3, 4, double bond is coming on the fourth position. If we come this way, double bond is getting on the third position. Position of CH group is fixed. But we cannot keep this double bond far. From this side also same position, that side also same position, then let's give respect to even these substituents. But if any difference is created, then we have to choose one, right? And certainly we do favor to double bond. We have to. So we'll say this the same thing. They are the 6-hydroxy. 6-hydroxy, cyclohex, and 3 in 1 carboxylic acid. 1 carboxylic acid. Yes, done. Do you need any aromatic system? Same, almost same rule, right now. On the aromatic also, almost same rule is there. You see this one, there. This one. Again, it matters. In this case, 2 CH groups are there. Ab now, here CH here. Ab now what to consider? These 2 CH groups we should consider, or the double bond? No. Both are the big boss. CH group, similar prime function group. So certainly we will give importance to this one. Then again you may start counting. This is there the law of inertia. 1, 2, 3 in flow. You start numbering like this, but highly mistake prone. Because why unnecessary double bond will be given there the higher locant? If we start numbering here, this is 1, this one 2. Both CH groups are getting 1 and 2 only. Whether you start from here to there or from here to there, both way 1 and 2. But if you start from here, unnecessary this one will be getting here 2, 3, 4, 5, 5th position for the double bond. But if you start from here, this one is 1, this one 2, this one 3, this one 4, 5 and 6. We get double bond also at the lower locant. And so we prepare this way of numbering and we say cyclo hex 3 in 1, 2 dicarboxylic acid. Dicarboxylic acid. Yes. In this one, very clear. Benzene, carboxylic acid. Certainly this one is the systematic IUPAC nomenclature. Benzene, carboxylic acid. But IUPAC name is even benzoic acid is the IUPAC name. Well accepted. Many of the common names are well accepted IUPAC name. So benzoic acid is one, right? Benzoic acid is also considered as IUPAC nomenclature. Let's take this one. This one is 1 now, this one second, this one third, this one second, third, on the third position only. If you go this way, third position BR. If you come this way, third position OH. What to do? Sir, OH is the functional group, sir. Functional group. Functional group is only one, COOH. Others are substituents. All other groups are treated as substitute. Then we will not give there the importance, no importance, alphabetical precedence, that's it, right now. And so this is 1, this one 2, this one 3, 4 and 5 and 6. We don't care. No emotional answer, right? And so what we do, we write here 3 bromo, 5 hydroxy, 5 hydroxy, benzene carboxylic acid, benzene carboxylic acid, carboxylic. Yes, I think you have done almost all kind of examples, and I can expect that you will be the master of this one. You have explored all possibilities. You have worked on all possible dots. And so now you can enjoy. Enjoy. Thank you.